Let's have a look at an example of complementary events and how complementary events can help us answer probability questions. Let's have a look at this particular scenario. The probability of rain on any day of a particular 3-day long weekend is 50%. So part A, we're going to list the sample space, and then part B, we're going to find the probability of at least one day on that weekend having rain. Okay, so there's two ways we can go about it. Either we can go about it listing basically all the days that, or all the situations where at least one of those days will have rain. So we could be talking about a Saturday, Sunday, Monday, all 3 days having rain. We could have rain on 2 out of those 3 days, and maybe rain on 1 out of those 3 days. And all of those particular outcomes satisfy at least one day. So there could be potentially quite a lot to count. The other way we can go about it is to find the complement of at least one. Okay, and the complement of at least one is none. Okay, so we'll get to that later, but it's just something for you to start thinking about now as we start to answer the question. So we're gonna let R be the event of rain. Okay, so the sample space is, okay, I'll try to squash it up a little bit so that I can fit it all in. So we get rain, rain, rain. So we've also got not rain. So the bar notation, okay, just means the opposite of. Okay, so we've got that. So I'm looking at basically all the situations now where rain on 2 days, but one day no rain. Okay, and we could have that, and there could be also 2 days of rain. So okay, I'll just have to break this up. Okay, and then we've got no days of rain there, and I'll just fix this one up here. We've got that there, we've got that there, and then we've got no rain, no rain, no rain. So the sample space, just go through that quickly. We could have all 3 days having rain. These next 3 events is 1 of the days being not raining and 2 of the days raining. So this could be, for example, Saturday, Sunday, Monday, for example. So 1 of those days will not have rain, the other 2 days will. The next 3 events in the sample space, or the outcomes in the sample space, the outcome of not rain, not rain, rain, not rain, rain, not rain, and then rain, not rain, not rain. Okay, so accounted for those 2 days not having rain, and then one outcome, or one particular interesting outcome, is no rain on any of those 3 days. So that will help us then for part B. Find the probability of at least one day on that weekend having rain. So the probability of at least one day rain is really just the 1 minus the complement, or the opposite of at least one day of rain. So probability of no rain. Okay, since the probability of getting anything in the sample space, okay, is 100% or 1. All right, so there's an even chance of all these occurring. Okay, there's no bias. It's nothing like that. There's an equal probability of getting any one of these 8 outcomes. So that's going to be 1 minus, okay, if we take out the outcome we're not interested in, that gives us then the remaining outcomes. Okay, so what we're effectively doing is that we're effectively taking out that outcome there, subtracting that from 1, and that gives us then the probability of the remaining outcomes, which are actually the ones that we're interested in. So that's going to be 1 on 8, which equals 7 on 8, okay, or 87.5%.